Hey everybody, welcome to Studio 64. My name's David. I've been searching the interzones for more science, space and tech news to share with you. Came across this at Indy 100. Yes, Mars could host life in vast liquid oceans, but there's a problem. Okay, well, let's find out what's going on here. Liquid water has been found for the first time on Mars in what could be the precursor to discovering life on the red planet. Now, experts have long known of the presence of frozen water at the Martian poles and have detected evidence of vapour in the atmosphere, but they've never been able to establish the existence of vast fluid oceans until now. Yes, the groundbreaking discovery of massive underground reservoirs was made thanks to data collected by NASA's Mars InSight lander, which landed on the planet back in 2018. Now, the lander was equipped with a seismometer, which recorded 4 years' worth of vibrations, also known as Mars quakes, from deep within the Martian outer crust. By analysing the quakes and movement of the planets, scientists have uncovered seismic signals of liquid water. Yes, now the issue they now face is this water is so deep underground they can't actually reach it, which, as I've said in previous videos, I can definitely understand it would be difficult. But, I mean, look at what we're doing in Antarctica with drilling ice cores. I mean, how far do they go down? Surely that technology will one day be adapted for Mars. See, they're only seeing with a very limited vision. By the time man does get to Mars, we'll have the technology, or we'll be able to develop the technology. I mean, seriously, come on. I mean, who would have thought that you could sit here at home in a room and make videos that the world could see just a few years ago? Interesting, isn't it? I mean, come on. The technology will definitely come eventually, but let's see what else they've got to say. And oh, by the way, I'll leave the link to the main article below the video, so you can pop in, check out the embedded links, go for a bit of a deeper dive if you want. Makes for an interesting read, believe me. And there's a little pic there of NASA's InSight lander. It touched down on Mars in May of 2018 and ended its mission in December 2022. Fascinating. Absolutely love this stuff. I grew up with the Viking landers. You know, first images coming back from Mars and all that sort of stuff. God, I'm a nerd. Love it. These reservoirs lie some 10 to 20 kilometres, 6 to 12 miles beneath Mars's rocky crust, and we simply can't dig down that deep on another world. Yet learning more about these extensive underground pools is key to furthering our knowledge of the red planet itself. Yeah. See, that's the thing. They're saying, oh, we can't do that in another world yet. Well, I think we will. I mean, a prime example is 1985 when Bob Ballard from the Woods Hole Institute, found the Titanic and sent down these little submersibles. That basic idea, that technology has now been adapted. So when we go to the moons of Jupiter and Saturn, say for argument's sake the moon Enceladus, and there is an ocean under its surface, we'll simply bore down through the surface. This is an ice surface with a heat sink, open that up, that hole up, and drop down one of these little submersibles that is designed for that, based on the technology from 40 years ago. All right? So in 40 years' time, I reckon we're going to be able to do this and we'll extract the water. It's quite fascinating. Absolutely incredible. Now, understanding the Martian water cycle is critical for understanding the evolution of the climate, surface and interior, lead researcher Dr. Vashon Wright of UC San Diego's Scripps Institution of Oceanography said in a statement. Meanwhile, his colleague, Professor Michael Menger of the University of California, Berkeley, added that water was the most important molecule in shaping the evolution of a planet. Studies on the surface of Mars, with its network of channels and ripples, show that the planet was once home to rivers and lakes, and yet for 3 billion years it has been a desert, which, as Professor Menger puts it, begs the question, where did all the Martian water go? Some was lost to space when Mars lost its atmosphere. However, as Professor Menger also pointed out, much of our water here on Earth is underground, and there's no reason for that not to be the case on Mars too. As I say, I'm not a scientist. I just love all science and sharing science, space and tech news with people, but, if there are any, and I mean any, astronomers out there, planetary scientists, exogeologists, please feel free to comment below the video. I'd love to hear from you. And look at this. This is a very interesting photo. It's an image captured by NASA's Mars Reconnaissance Orbiter showing an ancient riverbed. Absolutely fascinating. They're very similar to ones on Earth, I believe. So clearly Mars did have flowing water on its surface in the distant past. I think that's amazing. When I was young, no, that's not possible. Yes. Fascinating, isn't it? The InSight probe, which ceased operations in 2022, was only able to record vibrations from the crust directly beneath its feet. Now, we've got a little video. We've got a scientist being interviewed by Australian television, and it'll give us a bit more background into this discovery, and might give us just a little bit of a taste of what's going on with Mars and its water. All right, let's check it out, and we'll carry on the conversation when we come out the other side.
Well, there's new hope of finding life on Mars after scientists discovered there could be vast quantities of liquid water trapped in rocks beneath the planet's surface. Our space expert, Brad E. Tucker, joins us now. Brad, why has this got everyone excited about the possibility of life on Mars?
Yeah, look, we get excited when we talk about liquid water. Water is, we think, pretty essential to life. At least we know it here on Earth. We know it in other places that where we think of life, we think of water. And also liquid water is important because liquid water means it's temperate, that it's not too hot, it's not too cold, that it can be tamed in a temperate way, even protected underneath the surface. So that all means that the conditions for life are a bit more hospitable underneath the surface where there's waters found, rather than the kind of dry desert-like place that you get on the surface of Mars.
So how did scientists come to the conclusion that there could be water down there?
So this comes from the instrument, what we call InSight. So InSight was a probe working on Mars for about 4 years, and it was looking for seismic waves traveling underneath the ground. Now, the primary goal of these waves was looking for Mars quakes, like earthquakes, but on Mars. But they operate a little bit differently. And it's also able to measure then the density and composition underneath the soil. So they've been able to measure the structure of Mars, the layers of Mars. But as you look for the waves traveling through, they were able to see these liquid areas and a density that is fairly similar to that of liquid water on Mars. So it's a fairly similar technique to what we do on Earth in terms of monitoring and mapping subterranean areas and underneath the surface, but applying this now on our neighbor planet.
Is water alone enough to sustain life?
So that's a good question because, on Earth, we have water, we need oxygen and nitrogen, but we also need a temperate environment. Now, the question is, can other life exist in some extremes? And in fact, we know on Earth, there are some what we call extremophiles, things that live in the bottom of the ocean near even sulfuric vents from volcanoes. We know of things that live in the very inhospitable climates like the Atacama Desert in Chile. So it seems that water is good, but there's probably a bigger range for acceptance on, say, things like temperature. Now, that's big for Mars because Mars generally has a colder temperature than on Earth. The question then is of oxygen and carbon dioxide. We know clearly of plants that are carbon dioxide based, i.e. like on Earth. So we think that probably the conditions for Mars, assuming this is liquid water and it's fairly abundant, is right for having life, or at least hosting life in the past, and potentially even protecting it underneath the surface. So this is kind of why water's always been that key missing ingredient.
So could there be enough water there to put some humans on the planet to have a bit of an explore?
Well, so this is a great question because a lot of this water is deep underneath the surface. We think 10 to 20 kilometers underneath. So it's going to be a lot of digging. So this is going to be a challenge for future human exploration, which people are planning, not even colonization, but really NASA exploring and sending astronauts there, because this isn't going to be readily and sufficiently available to support those. So for humans, we're still going to have to find other ways of generating or producing water, which can exist. It's done on the International Space Station. It's a problem that we have to solve to some degree on the moon as well. So this discovery is almost less beneficial for us and our ideas, more beneficial for what may lie and live on our planet.
What else can Mars teach us about the universe in which we live? We do seem fascinated by all the findings on this planet.
It is, because in a lot of ways we feel Mars was so similar to Earth 3 billion years ago that probably our formation and origins mimicked each other. The redness of Mars is the same reason Australia is red. It's iron oxide in the ground. So there's a lot of similarities between Mars and Earth. And so if we look at Mars, we can understand potentially what could happen to Earth in the future, what may not just our future hold, but what could happen as a consequence of our planet, what could happen in terms of the environment changing or the atmosphere and how that affects the ground. It's a little bit of a future-looking work. It also then puts into range, how did Earth actually come to be? We still don't really understand how did life come about on this planet. We understand the ingredients, we kind of understand the requirements for it, but what gave it that spark, so to speak? Studying a place like Mars and looking for life gives us clues into what options there may have been to create life or start it and keep it sustaining. So you kind of, by looking outward, you can definitely reflect inward on our own evolution.
Brad Tucker, you're always a wealth of information on this. Thanks so much for your time today.
Thanks, Ange.
Well, that was very interesting, isn't it? I love it when you can hear, hear the news from actual scientists too. Sometimes it just gives me that, gives you another perspective, so to speak. Nevertheless, the experts believe there must be similar liquid water oceans lurking underground across the planet. If this were indeed the case, they estimate that there is enough liquid on Mars to form a layer across the surface more than half a mile, just over 800 metres deep. Still, they stress anyone now dreaming of tapping into those huge reservoirs as part of Mars colonisation plans has their work cut out for them. An illustration of the InSight lander and the water identified beneath the Martian crust. There we go. Yep. Now, I mean, basing it on that little tiny lander and here's the water down here. Now, of course it looks impossible. I mean, look at your little lander up here. Now, it's not designed to drill that far down anyway. It's only just designed to go just a few millimetres or, an inch or so below the surface. But as I say, it will happen. I have no doubt in any way, shape or form. The water is sequestered 10 to 20 kilometres deep in the crust, Professor. The water is sequestered 10 to 20 kilometres deep in the crust, Professor Manga told BBC News. Yeah, good on you, David. Can't speak. Must be the Catholic coming out of me. Drilling a hole 10 kilometres deep on Mars, even for Elon Musk, would be difficult. Yeah, have a go at Uncle Elon, that's the way. Bet the BBC love that. Yet even more exciting than the prospect of eventually harvesting or harnessing the water is the potential of what it might contain, evidence of life. Without liquid water, you don't have life, Professor Manga explained. So if there are habitable environments on Mars, these may be now deep underground. And as I say, I definitely believe, just in my observations of technology in general, that one day we'll be able to do this. I have no doubt in any way, shape or form we'll be able to tap these water reserves. There would be no concerns at all because, I mean, look, we go to Mars, we're going to have to take water with us. Yes, we can recycle our urine and everything else, but if you plan for a permanent colony on a surface like this, you're going to have to use the natural water reservoirs. So necessity is the mother of invention, as the old expression goes. So what you're seeing here at the moment is just, basically like one man walking across an entire continent. This is the equivalent, technological equivalent of one man walking across a continent and going, how the hell are we going to master this? Well, he managed to do it here on Earth. I know Mars is a long way away. We'll definitely be able to do it, I have no doubt. All right, well, my name is David. Thanks for joining me for another Studio 64 Science, Space and Tech News update. I shall see you in the next one. If you enjoyed this video, please like, share, subscribe. I'd greatly appreciate it. If you're up for it, drop a comment down below the video because I'd love to hear what you think. All right, take care. And as I always say, if you can't be good at it. And before I forget, Saturday, 11 a.m, Australian Eastern Standard Time, we'll have a live stream on Rumble, of course. And there'll be a link below the description of this video, so you can go to the live stream. Join us, and we'll have a little chit-chat about science, space, and tech. It'll be absolutely fantastic, and we'll get our nerd on. Absolutely amazing. All right, and as I also always say...
Fascinating.